Prospective mortality data is hard to analyze. Hi, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And in this segment, I'm going to be going over how to draw Kaplan-Meier tables or curves out of life tables. Let me go ahead and get started here. This is an instructional video as well, and using SPSS. I'll be using SPSS to analyze National Health and Nutrition Examination Survey. And this is a data set that I often use in many different types of conferences and paper derivations. This is actually 1999 to 2010 National Health and Nutrition Examination Survey, which is followed up through December 31, 2019. So there's quite a few years of follow-up, and I'm going to be going over that in a moment. So let's take a look at how we have to select in order to get a life table. So analyze, you go under analyze, and then survival, because it's a survival table. And then you can select life table. Now you're going to get a whole lot of numbers which may not make sense. So let's go right to it and go to a Kaplan-Meier curve. Now a Kaplan-Meier curve, there's only limited things that you can do with it. Usually the Kaplan-Meier curve is more applicable when you're conducting bivariate analysis. So what I did here is actually provide some strata here, which makes the figures a lot more complicated. So let's compare factor and take a look at log rank, linear trend for factor levels. And then let's take a look at options and make sure that survival tables, if you want to look at them, you can select them, but usually the mean and median survival is revealing. And then let's take a look at just survival, or log survival. So let me select these. So let me read this out to you first. What are some of the variables that go in each one of them? So for time, you want to look for something called, and this might be called different things in different data sets. However, here you have the status is mort stat, and then the interval period month interview is what you go through for time. And then for status, you look for MORTSTAT. Now, this is a linked mortality file, so this was generated from a linkage between the original file and then a mortality file in 2019. So taking a further look at this, now the factors are important. For all intents and purposes here, we're going to use rheumatoid arthritis. Now let's go back to compare factor. We checked log rank, checked linear trend for factor levels for each stratum, or you can pool over strata. And then options, mean and median survival, and then log survival for plots. So I want to make sure statistics is mean and median survival, and that plots are log survival. Then you're ready to hit OK. One thing I forgot to do here is define the event. So it's single value, and when you have one, that means there's a mortality event. Let's see what is being drawn here. As you can see, there's a nice curve that appears here, and what you can do is actually change some of the values within that are within the figure, and then make sure that the labels are informative. And you could just replace this month and years. Month or time, months. And we can just put time, and you can put in months. You exit out, and then go back to the curve, and now you have time there. So as you can see, what does this all represent? Well, this represents if rheumatoid arthritis is non-existent within the person, then it's not as drastic in mortality as if you were to experience rheumatoid arthritis or have a history. As you can see, with time, survival drops off pretty drastically. So then you see that there's a difference, and it's statistically significant. So then now you're ready to conduct your analysis, perhaps a Cox regression. Just a point to clarify, this is only true when you're not using complex samples. When you do use complex samples, there's actually a separate variable that I explain in another video. I hope this has made sense as to how to run a Kaplan-Meier curve. Thank you for listening.